Okay, so let's take a look on the second day of the pre-calculus preview practice. So for this set of the practice, again, we are going to learn most of this in our summer pre-calculus class. So if you feel like something you didn't know about, or you feel like the problems are too hard, it's okay, because we are going to learn this again in the summer. Alright, so let's take a look on the first problem. So for the first one here, we are trying to find the point of intersection of these two equations. And note that we have the two polar equations, but if you want to find the intersection, it's going to be the same idea. Alright, so first of all, you are going to set the two equations together. So we have r equals 3, and then the other one will be r equals 3 plus 2 multiplied by cosine theta. And we just want to find the solutions for r and theta that can satisfy both equations. And right away, we know that the r has to be equal to 3, right? That's going to be the radius, so the choice D here must be wrong. And then, if we set them equal to each other, this will be a 3 equals 3 plus 2 multiplied by cosine theta. And simplifying the equation, we will have the cosine theta is equal to 0. And the like if you are trying to find the solutions from 0 to 2 pi, then the theta can only be pi over 2. Or it can be 3 pi over 2. Alright, so here the correct solutions will be the answer choice A. Okay, so let's take a look on the second one. So for the second one here, we want to see which of the following is the graph of this point on the polar coordinates. So we know the first number represents the radius, and the second one represents the direction. And you can see that the 5 pi over 4 should be more than pi, right? So if you just take a look on each of the graph, only the choice C here is going to be the right angle. So this will be our theta equals 5 pi over 4. And then you also double check the radius. You can see that, well, the radius is going to be 2 units away. So the answer choice C will be correct. Alright, and now for the problem 3 here, we are going to have a sequence. So here we try to find the n such that the 2 multiplied by the f3 plus f2 equals the fn. So here, the f represents the numbers in the Fibonacci sequence. So by definition, we know that the fn is equal to the sum of the previous two terms, right? So this will be the definition of the Fibonacci sequence. So in this case, we actually have a shortcut to help us solve the problem. So you can see that we have the f2 and then we have the f3, and we try to add them up together. So actually we can make this into a f3 and plus another f3, so we can try to split the 2 multiplied by the f3 here, and then we have this equation. And then if we try to add the f3 plus the f2 together, it's actually a f4, right? Remember, we have the definition. And then when you add f3 and f4, the answer is going to be the f5. Alright, so this will be our answer choice, B. Okay, and now for the next two questions, we have some problems about the three-dimensional coordinates. So let's take a look on the first one. So for the first one here, we are trying to find the distance between these 2 points in the three-dimensional coordinate system. So to think about this one here, you can also use the three-dimensional geometry to think about the problem. So for example, you can see that if you try to somehow find, let me just label the points here. Like say that you have the axis to be like this. So this will be our x, and this will be our y, and this will be our z. So you can see that to find the distance between these points, if you find out the points to be over here, 3, 2, and 3. And then you have the other points, 1, 1, and 2. So just label this over here. So you can see that the distance between these 2 points, you can take a look here, can be represented like this. So if you think about the three-dimensional coordinates, right, we can actually take the differences in x and y value. So you can imagine you have a rectangular like prism, and then you try to find the length of the diagonal. So what we can do here is try to take the difference in each of the coordinates. So the distance is going to be, and then we are also going to take the square roots in the end. So it's going to be a 3 minus 1 to the second power, and plus a 2 minus 1 to the second power, and plus a 3 minus 2 to the second power. And then it's going to be the square root of 4 plus 1 and then plus another 1, which is going to be the square root of 6. Okay, and that will be our answer choice D. Alright, and now for the final problem here, we are trying to find the dot product of the two vectors. So to find the dot product, we can first find out the coordinates of the two vectors. So we can see that the first vector is essentially a 1, 2, and -1. So you can read this from the unit vectors. And then we try to find the dot product of the other vectors here, so -3 minus 2 and then minus 1. And then to find the dot product, you just want to multiply each of the corresponding coordinates and then add them up together. So we have a 1 multiplied by -3 plus a 2 multiplied by -2 and then plus -1 multiplied by -1. And therefore it's going to be a -3 minus 4. And then we have a plus 1, which is going to be a -6. Okay, or that will be the answer choice C.